Okay, the second part of section 6.3, still working with solving by elimination. But now, notice that if I were to add these numbers, they would not eliminate. And also, notice that if I multiplied by -1, excuse me, if I multiply by -1, these still won't become the same number. So today you're going to be working with terms that don't have the same constants in front of them. So we're going to have to make those numbers become the same. So you get to choose which one you want to do. So for example, in this case, I could choose to eliminate the x's, or I could choose to eliminate the y's. If I choose to eliminate the x's, then I need to make these numbers here become the same. So the first thing I would always think about is, can I multiply the smaller number by something to make it become the bigger number? So in this case, you could multiply it by 5. I could also try and eliminate the y's if I wanted to. And so since there's a 1 here, I would want to think about what could I multiply this smaller number in order to get to 7, so I could multiply by 7. Sometimes people just end up swapping these two and multiply by 7 down here and multiply by 1 up there. It is your choice. I always check to see if I can put the smaller number into the bigger number first and then go that route. So again, I decided to eliminate the x's, so that means I'm going to have to multiply everything by 5 on this bottom equation. So my top equation will not change, so I just rewrote it. My bottom equation now is going to get multiplied by 5 all the way across, so make sure I'm getting every single term. So this becomes 10x, this becomes 5y, and that 7 on the end will change to 35. So notice I multiply all the way across because that seems to be an error sometimes. Now I'm going to check to see if they eliminate. So I'm going to add my x's. They eliminate to 0, which is what needs to happen, so I don't have to multiply by -1. So if there was a case where it didn't eliminate, then you would want to multiply by -1. So now I would add my y's and I'd get 12y, add my constants and get 60, divide by 12, and I would end up with y equaling 5. You have 3 options to plug back into. I always go back to an original one. So in this case, I went ahead and just chose the bottom equation and I put 5 in for the y spot. So now I have 2x plus 5 equaling 7. I'm going to subtract that 5 over so that I can combine it with its like term. And then I need to divide by 2 in order to get x by itself. So x would be 1. So my final answer would be 1, 5. Okay, you're going to pause the video now and try the second one. So on this second one, you have to understand one thing. There are a lot of different ways to go about doing these problems. So the way that I have solved it does not mean it's the exact same way you did. So if I was going to try and eliminate the x's, I'm thinking of a number that I can have 5 and 8 go into, because 5 does not go into 8. So the number that both of them can go into is 40. So I would have to multiply the top by 5 and the bottom by 8. So if you eliminated the x's, that's what you would want to do. In this case, I decided to eliminate the y's because all I'd have to do is just multiply the bottom one by -2. Now, you can multiply by a +2 first and then come back and multiply by a -1 because remember, we need these to eliminate, so they have to be opposite signs. If you cannot see that, then break it down into 2 steps. Otherwise, you can do it in 1 step and make sure that you take care of the negative here. So it is your choice. So I decided to multiply by a -2 on that bottom equation. So this became +10, -2, and then a +56. So I did not change the top one, I just multiplied the bottom one by a -2. Now I'm going to check to see if they eliminate. When I add my y's, they do eliminate. So in this case, if they don't add to 0, you would want to come back and multiply by a -1, like we did previously. Okay, since they eliminate, I'm going to go ahead and combine like terms. So I'm going to add my x's and get 18x, add my constants and get 72. Now I'm going to divide by 18 and I would get x equaling 4. I'm going to plug back into one of my equations. In this case, I decided to plug into the top equation, so I put 4 in for x and times by 8 and got 32. I am now going to subtract 32 over here with 16 and get -16, divide by 2 and get -8. So for your final answer, you should have 4, negative 8. Okay, let's take a look at another example. In another example, we have same, still trying to solve by elimination. You still get to choose which one you want to do. So if I was going to eliminate the x's, 2 does not go into 3, so I would have to think of a number that 2 and 3 can go into, which in this case would be 6 when you multiply. So I would have to multiply the top by 2 because 2 times 3 is 6, and I'd have to multiply the bottom by 3 because 3 times 2 is 6. You could also try and get rid of the y's if you wanted to, and so in this case 2 doesn't go into 5, so I would think of a number that 2 and 5 go into, which is 10. So I would have to multiply the top by 5 and the bottom by 2. I decided to eliminate the x's, so I went that route and multiplied by 2 on the top, changing it to this, and then I multiplied by 3 on the bottom, which changed it to that. Do make sure you multiply all the way across so it does not stop. Each term will get multiplied. Now I check to see if my like terms will eliminate. So these do add to 0, so I'm good to go. So then I would go ahead and add my y's, which is negative 19, add my constants, which is 76, divide by that negative 19, and I would get y equaling negative 4. Then I'm going to plug that back in, and I now have 4 different options, but I'm going to take one of these two originals. So I decided to take the top equation, and I put in negative 4 for the y. So I'm going to go ahead and multiply negative 2 times negative 4, which is positive 8. Then I'm going to subtract that 8 over with the 17 to get 9, and then divide by 3, so I get x equaling 3. You're going to pause the video and try the last question. So in the last question, you can again decide if you want to eliminate x's or y's. So if I was going to eliminate x's, I would need the constant in front of the x's to become 20. And if I was going to eliminate the y's, I would need the constant in front of the y's to change to 6. So I decided to get rid of the y's so that my numbers stay smaller. So I'm going to multiply the top by 2 because 2 times 3 is 6. And I'm going to multiply the bottom one by 3 because 3 times 2 is 6. Now one other change, these currently have the same sign and I need them to be opposites of each other in order to eliminate. So again, I put one of them as negative in order to take care of that. You could wait until you get to this second step and then multiply everything by negative 1 like we did previously. So it is your choice. So on the top equation, when I multiplied by 2, it changed over to 8x minus 6y equals 16. I multiplied the bottom by negative 3, so all of those will change signs. Then I checked to see if my y's would eliminate, and now they do because they have different signs. So then I added my x's and got negative 7x, added my constants and got 49, divided and I got x equaling negative 7. Then I went back and plugged it back in, so I decided to plug in this top equation. So I did 4 times negative 7, which is negative 28. I added 28 over and got 36, and then I'm dividing by negative 3. So final answer should be negative 7, negative 12. Okay, so with elimination, again, you still want to make sure your x's or y's eliminate, but you want to make sure that you're getting that constant to become the same. So you're thinking of a least common multiple that the numbers would go into.